Uncle Dude here, and today we're going to talk about exponential functions. What is an exponential function? Well, I'm going to give you two functions and you think about which one it is, because my students get these confused. If I look at this one and I look at this one, they get these a little bit confused. Well, the exponential function is when the variable is in the exponent. So this is the exponential function. This one is a quadratic. It's called a quadratic equation. This graph looks like that. And this graph looks like that. Okay? So as long as the variable is in the exponent, that's an exponential function. And I'm going to give an example of it right now, how it grows, because this thing takes off. This growth is a little bit slower, usually. So let's take a look at an example of an exponential function. I'm going to take a piece of paper, and we're going to see how many rectangles we have depending on the number of folds. So obviously, if I don't fold the paper at all, that's 0 folds. And the number of rectangles I have is just 1. Nice. That's nice. Now, if I fold it with 1 fold, how many rectangles do I have? I have 2. So 1 fold gets me 2. Now let's fold it again. So I folded it 2 times. Open it up and count the rectangles. 1, 2, 3, and 4. So this. If I fold it 2 times, I get 4 rectangles. Now, I'm folding it again. I'm folding it 3 times. Now open up the paper. 1, 2, 3, 4, 5, 6, 7, 8. So when I fold it 3 times, I get 8. And if you want to try one more fold it 4 times. I folded it 4 times. What do you think is going to happen? I hope I'm not too low for the camera. And now, how many do you get? Well, you open it up, and the Oscar goes to, well, now when you count it, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. Wow. This is growing exponentially. And let's see how we can write a formula for it. Well, if I call this x, right? Then what is happening here? Well, this was a power of 2 because what we're doing is we're taking the base 2 and we keep folding it. Each fold is going to be the exponent. So this one is really 2 to the 0 gets you 1. This is 2 to the first, this is 2 squared, this is 2 to the third, and this is 2 to the fourth. That's how we got those numbers. So the function is really f of x equals 2 to the x. That's the function. F of x is 2 to the x. Okay? There it is. So if you put in 5 folds, you're going to get 32 rectangles, and it grows like that, and that's how the population is growing. And I'm just going to show you one quick example on that using rabbits, making this up. Just say there were 20 rabbits and they triple every half year. I put half hour. They can't do it that quickly. Every half year. Right? 20 rabbits. Every half year. So when you start off at 0 with the time, you're first starting with just 20 rabbits. Then, in time of half a year, this is tripled. So it becomes 60 rabbits. Then in another full year, this is tripled again. It becomes 180 rabbits. Let's just do a couple more. Another half year is 1.5 years. You triple this, this becomes 540. Right? And then after 2 years, if you triple this, you're going to get 12, 1, 16, 20. So you have 1,620 rabbits only in a 2 years' time. So let's figure out how that works. Well, these are powers. You're starting with 20. This is 20, 20, 20. These are our bases. Times 3 to the first power. That's how I got 60 here. So this one has to be 20 times 3 to the second power. Let's try that. That's 9. And 9 times 20 is 180. This is 3. And 3 times 20 is 60. This has to be times 3 to the what power? 0. That gets you the 1. And 20 times 1. And that pattern just goes. This is to the third, and this is to the fourth. So how can we come up with a major pattern to this? Well, you're going to start with 20 times 3, and look at the numbers here. The only thing that changes is that this 0 stays the same, but this 1/2 goes to 1. This 1 goes to 2. This 1.5 goes to 3. So each time what you're doing is you're multiplying by 2. This 2 goes to 4. So if I wanted to get a function of this, you would say f of x equals, you take the 20 times 3 to the what power? Well, we have to double those half years. So there it is. Oh, now here's a mistake I just made. I put a t. These letters have to be the same. So I'm either going to put a t and a t or an x and an x. So let's just make this into a t. There we go. So it's f of t equals 20 times 3 to 2 t's. All you have to do is put in any time you want. If you want 10 years, you put a 10 in here, and this will be 3 to the 2 times 10 power. Times the 20 will give you the number of rabbits. And it's an explosion in the population. Okay? Well, this has been Radical Dude, and I hope I was able to teach you something. Thank you.